Greetings and welcome to the video on practice problems for a practice problem for the independent t-test. So you see I have some data already kind of loaded up here on the video, and what this data represents is human blood clotting times in minutes. So there's units after each one of these values for drug A and drug B here, for the drug A group and the drug B group. Those are minutes, so 8.8 minutes, 8.4 minutes, so on and so forth, for individuals given two different anticoagulant drugs. And so basically, where do I want to start? Let me start first with what this design would look like, right? So we have 1, 2, 3, 4, 5, 6. N equals 6 in the first group, and they were randomly assigned to get, we'll call this treatment A, and then we're going to make an observation and their blood clotting times. And if you count the number of individuals in group drug B, it's 1, 2, 3, 4, 5, 6, 7. So we have N equals 7 that were randomly assigned into getting anticoagulant drug B, and we're going to make an observation on their blood clotting times. Okay, so that's the design. What is the null hypothesis here? So the null, remember I like to write these as a statistical. There's two ways to do this. You always do it with population parameters because remember this is inferential statistics. So we have taken a sample from our population. We're measuring blood clotting times between these two groups that are a sample, and then we want to infer those back to the population. So the null is really about what's happening in the population, so we use population parameters. So instead of x bar, we're going to use mu. So we can say that the mu of group 1 is equal to the mu of group 2, or you could say this, I guess kind of a more mathematical way would be saying that the mu of group 1 minus the mu of group 2 equals 0. And then the alternative hypothesis would be that the mu of group 1 is not equal to the mu of group 2, or another way of saying this would be the mu of group 1 minus the mu of group 2 is not equal to 0. Okay, so that's our kind of our baseline from where we're starting. So then let's, I guess, also then put up kind of our prevailing equation here. So our prevailing equation for the independent t-test is the mean of group 1 minus the mean of group 2 divided by the standard error of the differences between the two means, and we do that through that pooled variance formula. So this is kind of our prevailing piece here. Okay, so if you go back through our steps, you know, step 1, which was kind of rewriting our nulls and so on and so forth, there it is. Step 2 was finding kind of our comparison distribution here, and the comparison distribution is going to be on degrees of freedom of what here? When we're doing a t-test, a t-test is going to be off of n minus 2. We have two different groups here. So the new value is going to be n minus 2. That's our degrees of freedom. Okay, so that's going to be our comparison distribution for step 2. So this would be nu equals 13 minus 2 equals 11. Okay, so we're going to look for a curve then, right, a t-distribution curve. We're going to look on that curve for our critical cutoffs. That's going to be based on whatever this curve shape is, and this is going to be arbitrary, but whatever this curve shape is for the t-distribution, the shape of that is based on nu equaling 11. Okay, so whatever our cutoff regions will become will be based upon that degrees of freedom value. That's kind of our step 2. Then the step 3 was, well, what is our critical t? So Our critical T here is going to be a T at 0.05, two-tailed, with 11 degrees of freedom. And if you look that up in a T table, and you can find these T tables online, in the back of your book even, is going to be 2.201. Okay, so that's going to be your critical or cutoff T. Okay. All right, so let's then kind of plug and chug here. So step 4 then really becomes kind of calculating our actual T. So let's do this. So let's look at what is the N here for group A. The N equals 6. Degrees of freedom for group A is 6 minus 1, which equals 5. The mean then for group A, and I'm not going to go back through all these formulas, I'm just going to assume at this point you know what the formula for a mean is and I'm going to keep the minutes in, or the units in here. This is going to be 8.75 minutes. I'm going to get the variance here for group A as 0.339, and the units here would be minutes squared. And then when we take the square root of this to get the standard deviation of group A, then this will be 0.582, going back to the units of minutes again. For group B, the N of group B is 7. The degrees of freedom for group B is 7 minus 1 equals 6. The mean of group B is 9.74 minutes. The variance for group B is 0.669 minutes squared, and then the standard deviation for group B is 0.818, and we're back to minutes again. So if you have any questions in particular, I guess, about maybe variance or standard deviation, I would encourage you to go back to your notes and go back through the previous videos that dealt with these particular concepts. All right, so if we've got the means, which is 8.75 for group A and 9.74, we've got this numerator part licked up here. So what we need to now get and find out is this piece down here. Well, if you remember your formula here, we said that this term, the standard error of the difference between the means, is equal to the square root of the pooled variance divided by the sample size or the total size of group 1, and this pooled variance term again divided by the sample or the size of group 2. So we got to get this pooled variance term, this s squared sub p, and get the s squared sub p. And again, this is going back to the previous video. I won't bore you with all of the equations here. This is going to be taking the degrees of freedom for group A, which was 5, dividing by the degrees of freedom total, which was 11, and then multiplying by the variance for group A, which is the 0.339 value, and to that adding the degrees of freedom for group B divided by the degrees of freedom total multiplied by the variance for group B, which was 0.669, and when you kind of plug and chug this, you'll get 0.154 for group A plus 0.365 for group B, and so your pooled variance total when you add group A to group B will be 0.519, and it's because this is a variance, the units with this are minutes squared. Okay, so that is our pooled variance term. So to get back to the standard error of the difference between the means, we need this pooled variance term, which is then going to be 0.519 divided by 6 plus 0.519 divided by 7, and take the square root of that. That is this piece right here. And when you plug and chug this, you get 0.086 plus 0.074 square root equals the root of 0.1608 equals 0.40 minutes is our unit here. So then when we calculate t, what do we get? Using our formula from above, we already had the numerator, which was 8.75 minus 9.74. And then we divide by our standard error of the mean difference term here, which is right here, which is 0.40. And you get negative 0.99 divided by 0.40, so you get negative 2.475. So what is this value? This value here is calculated t. Calculated t. What is critical t? Let me go back to blue real quick. Right here is critical t, or our cutoff t. This is calculated t. So at the end of the day, we now need to make a decision. So I'll call this 5. And what is our decision? Negative 2.475 absolute error bars is greater than, that was an ugly greater than sign, let's try this again. 0.475 is greater than 2.201. So our calculated t, right? Calc t is greater than crit t. And so what's the decision? The decision is to reject the null. What is the null saying? The null is saying that you can consider these two the same means. We can't consider them the same means. So that means that one of these drugs did better at blood clotting times than the other drug did. And so that would be the conclusion that you would make. You would actually have to go in here then and say, well, which one was the better drug? There's no follow-up test. You just have to provide an interpretation. Well, it's the mean of group A, so anticoagulant drug A, reduced blood clotting time relative to anticoagulant drug B. Okay, so that is the big picture. I'll do one other quick video as an alternative method on this. Thanks for watching this video.